Hi, now these are three selected questions from the assignment number 5 on Newton's laws of motion and the application of it. In the first question, Mary applies a force of 74 newtons to push a box with an acceleration of 0.49 meter per second squared. When she increases the pushing force to 86 newton, the acceleration changes to 0.74, and there is a constant friction force between the floor and the box. You've got to find the mass of the box. Now, there are two specific cases here, and therefore we could set up two equations and solve the two equations to find the mass. Now, what are the forces acting? One is the force of the push, the other is the force of friction acting exactly in the opposite direction. Therefore, the net force would be Fa minus Fk, that's the force of kinetic friction, is equal to mass times acceleration. On substituting the values given, 74 minus Fk is mass times 0.49, and in the second case 86 minus Fk is mass times 0.74. So you've got the two equations, and to solve the equations, let's subtract equation 1 from 2. The idea is to get Fk cancelled, because you're going to have negative Fk plus Fk. So we are subtracting 1 from 2. So on the left hand side you have 86 minus 74, which is 12, and on the right side you have 0.25 m. So divide 12 by 0.25 and you get the mass as 48 kilograms. In the second part of the question, you're asked to find the coefficient of kinetic friction between the floor and the box. We know that friction depends on the normal reaction. Now, I've shown the weight acting vertically down here, and the normal reaction is in. And friction is mu k times n, which in this case is mu k mg. So substituting the value of the mass into equation 1, we can find Fk from that. And then substitute Fk into this equation to find mu k. When you calculate mu k, you get 0.107 as the answer. In this question, a child leaves her book bag on a slide. The bag is at the top of the slide, starts from rest and reaches the bottom in 1.34 seconds. The mass of the book bag is 3.80 kilogram. The length of the slide is 2.70 meter, and the angle of incline is 33.5 degrees. We have to find the acceleration of the bag. Now we know that the initial velocity is 0 in this case, but before we get to that, the angle is there, and drawing the free body diagram and taking the x-axis along the inclined plane, you see that mg sine theta acts along the inclined plane and mg cos theta at right angles to the plane. You have friction against the motion and the normal reaction. Now, the initial velocity is 0. The time taken is 1.34 seconds. The displacement is 2.70 meter. And then we have to find the acceleration. We use the equation delta x is equal to v naught t plus 1/2 at squared. And substitute what is given. Of course, the first term here becomes 0 because v naught is 0. So when you work that out, you get 3.01 meter per second squared. In the second part, you are asked to find the friction force acting on the bag. That's the x, that's the y-axis. And taking the net force along the x, you see there's mg sine theta down minus fk up should be equal to mass times acceleration. That is Newton's second law. Net force is equal to mass times acceleration. Make fk the subject, becomes mg sine theta minus ma. You know the mass? G is 9.80, sine 33.5 minus, well, of course I've taken mass outside as common, that's why you see that there, and I've used the value of acceleration that I got. I get it as 9.13 Newton. And then to find the coefficient of kinetic friction, we use Fk is mu k times n, but in this case the normal reaction is mg cos theta, as you can see. So when you substitute Fk is equal to mu k times mg cos theta, and Fk is 9.13 Newton, that's equal to mu k 3.80 times 9.80 times cos 33.5. On solving that, you get mu k is equal to 0.0294. Okay. Remember that the coefficient of kinetic friction has no units. So those are the three parts of that problem. And in the next, there is a fourth part, a part where you have to find the speed of the bag when it reaches the bottom of the slide. That's calling for the final velocity, which is initial velocity plus acceleration multiplied by time. So you have 0 plus 3.01 times 1.34. You get 4.03 meter per second. That is the final velocity of the book bag as it reaches the bottom of the slide. That takes us to question number 3, where you have this arrangement of a block of mass 38 kilogram on a horizontal surface connected by means of a string to another mass of 14.7 kilogram, and the coefficient of kinetic friction is given, and we have to find the acceleration of the hanging mass. Now, treating this as a free body diagram, we consider the forces acting on each mass individually. So the mass here, M2 is 14.7 kilogram, M1 is 38. The weight of this M2 is M2G actually, M2G, and the tension is T. Now those are the only two forces acting on M2. And when we look at M1, the only force acting along the x-axis is the tension. Well, definitely there is the weight acting down and the normal reaction. We'll get to that in a minute. But along the x-axis, there's only tension. So, and of course there is friction. Pardon me on that. There is tension and there is friction acting on M1. Yeah, there would have been no friction if it was a smooth frictionless surface, but in this case there is friction. So considering the net force on M2, that's along the y-axis, there is M2G down minus tension up, which is equal to mass times acceleration. So I'm going to make that M2 now. Okay. So that's 14.7 times 9.80. minus tension, which we do not know, is equal to 14.7 times A. And considering the net force along the x-axis, that is on the object of mass m1, we have two forces. Obviously T is greater, so T minus Fk is m1A. First, let's find Fk. The force of kinetic friction is mu k times the weight, that's weight of m1. Coefficient of friction is given, so you multiply that with 38 times 9.80 to get the coefficient of kinetic friction on m1. So now we have tension minus 96.82 is 38A. So we got equation 1 and equation 2. If we add these two equations, definitely we're going to get tension out of the way. So add 1 and 2, and you have to multiply 14.7 times 9.80, then minus 96.82. That gives you 47.24 is that, and the acceleration is 0.896 meter per second squared. The B part of this question says find the tension in the chord. Now to find the tension in the chord, you just substitute the value of A into any one of the equations. I'm substituting it into equation 2, which is here, of course, and when I substitute, T minus 96.82 is 38 times A, which is 0.896, and on multiplication of those two terms I get 34.05, and then to find T, take negative 96.82 to the other side, so it becomes positive. Add those two numbers and we have 131 newtons, considering the significant figures. Well, I hope this is helping somebody out there, and if my YouTube videos are benefiting you, why don't you please go ahead and post some comments so that I can make it better. So do go onto my YouTube channel and post your comments. I appreciate your honest comments. Thank you.